So I think I can answer a lot of questions that you were asking. Basically, the motivation for this work is that I see a lot of findings recently floating into machine learning, artificial intelligence, and big data. However, when we talk about if we want to put some money for ontology, investors or founders, they are kind of hesitate if we say, let's build this ontology. And then as ontologist, just myself, moving to NIH to do this data scholar program, I'm thinking I have been thinking actually 4 years ago, I talked to Rob, asking him, how would your machine learning method to really leverage the semantic that ontology is built? Just the question that Gandalf was asking. So then I think the good way to start is just to look at what the literatures are out there so we can have a landscape analysis. It's not moving. 1 sec. Okay. So we know that ontologies are built with semantics relations, but then all those graph theories and the data metrics are transforming the whole ontology into numeric input to the machine learning methods. But then how they do it and who is doing that? Exactly the question that Rob was asking in the beginning. I'm interested in knowing that question too, because then we build a community, then we can have better result. All right, so then I started to look at Google Scholar. Oh my God, 2,000, almost 3,100 papers. And then I said, okay, I'm looking at the biomedical study. So I go to PubMed. It's good, I only find, and I use better keywords. So I use ontology, machine learning, artificial intelligence, deep learning, and the neural network. And I found 1,324 results. And then but I just want to do a very quick overview. So I did some filtering, and I found the last 5 years composed 60% of paper out there. So I decided to use 5 years. And eventually I went to the PubMed Central. Why is that? Because I can quickly look at the full text. I can look at their methodology, technical details to determine if this paper is fitting to my question of how was ontology used in AI and machine learning to solve biomedical questions. So the cutoff date is the 4th of September, filter 5 years, search strategy, as I said, but I later on add embedding because I see a lot of papers are talking about embedding. So by doing this, I ended up with 503 articles. And note that the PubMed Central, they are ordering the papers by relevance. So I screened 250 papers by relevance. So I think it's a very good representation of the 500 papers out there. And then there are some papers doesn't have a full text or preprint that I excluded. And then I did some eligibility screening. So I ended up to have 108 paper to look. So the findings. The findings that I found after 2018, we see an exponential growth there. And I think this result is a little bit biased because suddenly I remember I just filtered 5 years data, right? So, but still, it's a big growth. And since we are putting a lot of money funds in the AI ML, I'm thinking that we will have more in the next 5 or even 10 years. So, and then I look at who and where are those researchers are conducted. So it's very interesting to look at this map. USA is the top one published country, 33 papers. And the second is China, 26. And then is Saudi Arabia and UK, 10 by each. And then some countries in Europe, and then Korea has 4 papers. And there are also some, I want to see how the countries collaborate with each other. Turns out that China and the US combination on the top one. And then Lebanon and France. Saudi and the UK only have one paper, which is surprising. But maybe so I will talk about my limitations towards the end. I missed a lot of papers for sure. And I also did a researchers network. So what I found is also very interesting. A lot of, I see a lot of isolated group of researchers, right? And then I found that Dr. Hondo, he is a hub for this whole research area at least. And he composed 2 red dots here from UK. This one is another our co-organizer for this workshop. And China, because China has a lot of papers, so they actually formed a couple of in-China collaborations. Means the authors participate in multiple papers, at least 2. That's why we form different kind of community there. So the conclusion here is that we need more collaboration and we need more roving workshop, that's for sure. And also look at which ontology are used the most. So unsurprisingly, it's not surprised that gene ontology composed 57% of all the papers out there, that the 108 papers I screened. And then next will be really, they are not comparable to gene ontology at all. The Snowman CT, HPO, UMLS, DO, and on the right side of the screen are all those other ontologies really only appeared once. But if you are looking at, take a good look, I put a mark there. Those are disease or phenotype or condition-related ontologies. So if you add them together, they are composed 35% of the papers. So they are number 2. Number 2 is about disease phenotypes and conditions. So, and then I think, okay, so which one will be the next GO? I think the next one will be a disease phenotype condition ontology that harmonizes all those things, but I might be wrong. And I also looked at what questions the researchers are asking when they write a paper, and I put them into 4 categories. From this word cloud, you can see a lot of papers are on gene or protein functional predictions. There are a lot of papers out there. And then also a lot of papers using machine learning, artificial AI, ML for the ontology annotation. Ontology, I'm not talking about Go ontology and cell ontology and all other conditional ontologies as well. And then papers predicting gene-protein interactions and disease-specific genes, proteins, or variant predictions are. And then you have drug-related papers, drug-drug interaction, drug repurposing, we just heard one, drug target, drug toxicity, and then prediction of the pathway membership. Then you go to clinical, it's very limited. Clinical, mostly the papers are clinical outcomes prediction from the EHR. And there are a few papers too, trying to predict the anatomic site, predict from the radiological report, image, or pathological report. And then there's one paper looking at the patient similarity for clinical trial. So the third bucket is the social media, using those methodology for social media data. And a couple of papers using it to predict the sentiment. One paper, very interestingly, using tweet to predict drug off-label use. I think it's a very nice paper there. And then others will have some predicting the hierarchical relations in an ontology or part of relation, or just in general ontology relation prediction and their recommendation systems using those methods and ontology. Okay, so we know that in the biomedical field, we have a lot of questions. So I think we really need to get to those methods to apply to more broadly many other biomedical areas. That we need community help. So then I look at, okay, what are the ways people are using ontology for, this methodology, right, the mechanics. So one is, the big category is use data for the category, use data as a training data set, or use ontology as a classifier target. And then another bucket is, I use the ontology as a part of the machine learning method so that I can compute those knowledge. So I found 39% that are using embedding, semantic, similarity, or information content. So this is exactly how you are transforming all those words and the relations into a numerical data matrix. They use all kinds of ways to try to get a numeric presentation for what ontology is coded in. So I see a lot of fantastic papers out there. However, we're really lacking of those ontology used for meaningful input into the neural networks. There are some papers using the ontology and the ontology annotated data form the network as the layer of the neural network, but not too much, not too many. So it's still lacking. And then I also look at what are the popular neural networks or deep learning or all methods out there. So the neural network is the top one, probably related with my search word, but the convolutional neural network has a lot of paper using that, and then any other neural network. And today I learned about graph neural network. So there are a lot of neural network out there. And then we have some papers on deep learning. We have a lot of papers on using vectors, transformation methods. So we have node-to-vec, word-to-vec, doc-to-vec, onto-to-vec, OPA-to-vec, DL-to-vec. And I just noticed there is a edge-to-vec, the previous talk. And then still people are still using the classifier, the traditional ones. Random forest, SVM, logistic, Bayes, and KNN. So there are still, people are still using it. Okay, so what we need here, as I said, we need a more paper to think about how we utilize the full powers of ontologies in those high and AI ML methods. So I saw out there are semantic web AI, explainable AI, which are the possible solutions, and also learned that there is a neural symbolic approaches that can be a possible solutions. I think we need to implement that. But as I need to put a question there, and I will talk more in my panelist discussion, that those predictions we really need experimental validations and the ontology constraint checks. All right, so the limitation for this work, and it's ongoing work, I'm still working on it, is that the search strategy, we may need to refine the search strategy, and also ontology, the database choice. I only choose one database. There are a lot of more out there that I need to search, and I might need to refine eligibility. And there is a lack of standard and terminology for those AI ML systems frameworks. Fortunately, I found one paper who is developing this kind of standard terminology, so I can use it for my future work. So my future work, I will expand the database. Besides completing current work, I expand to other databases, especially the Europe PMC and some computer science databases like IEEE, DLP, PMLR, R, and also some preprint database. Then, as I said, I use the terminology to really put it in a standard form so I can analyze better. And then I will do more deeper dive into looking at how the user input data, what methods they're, what hyper parameters they're using, and what training data they're using, and what performance evaluation parameters they're using. So then I can maybe build a database, website, everybody can search. All right, so this work is done by some of my high schoolers. I have a volunteer group, Biomedical Informatics Research and Data Science. So the high schoolers that help me to prepare the data. And I also have 2 other data scholars to join me. Oh, by the way, so the data scholar is a special program from NIH. The full name of that is Data and Technology Advancement. So it's a 1-year or 2-year program to get some senior technical people to help NIH for a lot of data science heavy projects. So I have 2 other data scholars join me. With that, I thank you.
I have questions or comments. So a lot of your graphs include the quantity of papers. Though when looking at the quality over year, do you think something like an H score would help determine H scores would help determine quality, or how would you look for quality in paper?
Oh, I'm not familiar with H score.
Like citation numbers.
Oh, okay. I didn't
It's
look
based
into.
on authors. Right?
Yeah, I didn't incorporate it in that because I just want to have very quick, like, view of what is happening. Right, but I should add it later. Yeah, thank you so much.
Did you work with or consult with a librarian with your search strategy at all?
No, I did a lot of literature reviews at FDA. So, and yeah.
Okay. I've used them in the past, and when it comes to coming up with the
They have a very big one, yes. But my point is, I want to search very broad way of searching.
I see. Okay.
Yeah. I forgot to repeat the question to the.
Oh, yes, it would be.
Yeah, the first question was about, do I use the H score, like the citation, including citation for the for the paper's quality? I didn't, and I didn't know H score, so I will use it for my future work. And the second one was asking, do I ask a librarian help? I said no, because I did a lot of literature review.
Yeah, thanks for sharing that. I think you're right. The research you did can help answer some of the initial questions. I think you can, I would like to suggest that you can multiply your impact by using, when you say you found that these kinds of activities were performed, such as classifying within ontology or using ontologies within a layer, that you could actually classify those outcomes according to classes in their ontology, like the artificial intelligence ontology.
Yes.
And you could do the same thing for when you describe the different, which ontologies were most frequently used in ontology AI.
Yes.
You could try to form an ontology of ontologies and say, what are the characteristics that have made SNOMED more useful than the plant ontology, something like that. And you could even, one of the questions could be, are the ontologies that are most useful for machine learning, are they more A-box rich or are they more P-box rich? Because SNOMED has a good mix of both, whereas something like, so if you speak purely in terms of the Go ontology, not any classification, the Gene ontology is mostly T-box.
Gene ontology, I see most of them using the annotation of gene ontology. Couple of, those are great questions. So I repeat the question. He gave me a couple of very good suggestions. One is using artificial intelligence ontology to classify my result. That was in my future plan. I agree with you. The second, what is the second?
You need artificial intelligence ontology to classify the activities that we use, and also things, could you could you make an ontological model of which ontologies are most useful and what
Okay.
is distinguishing features?
Right. And the second one, he suggested me to, is Mark. He suggested me to develop ontology of ontology and to find out which are the most popular ontology and find out if the ontology is being used as T box or A box. So I have seen that gene ontology has been mostly using gene ontology annotation. And I noticed this. When I search gene ontology in the PubMed, I exclude a lot of papers because a lot of biomedical, bioinformatics paper, they will do a prediction. They will do a expression gene analysis, and then they coupled with the gene ontology enrichment. So that is a big thing I have to filter out. I filtered out a lot of papers on that. So if you search gene ontology, you got a lot of things that you have to get rid of for my purpose. Well, thank you so much for all your suggestions. I actually need to recruit people to work for this. Not